So after setting excavation support and dewatering from the site, we are finally ready to design foundation. So let's look at the foundation design. Before we discuss the foundation, we need to know the terminology of the building structure. So building always divided by three parts: superstructure, substructure, and foundation. Superstructure locating above grade level, and substructure below the grade level. And then below the substructure, it is called as the foundation. Okay, so foundation can divide by the two categories: shallow footing and deep footing. The shallow footing occur close to the bottom of the substructure. If you design the foundation just bottom of the substructure, it can called as the shallow foundation. But if you extend it to deeper and more competent soil, if you're just designing some foundation here, it can called as the deep foundation. So just understanding about the shallow foundation and deep foundation. So it divided by these two depending on where is the competent soil located. If competent soil located like bottom of your substructure, it can be shallow foundation. However, if you have to make it deeper to find competent soil, it is called as deep foundation. So let's talk about the shallow foundation first. Shallow foundation mostly categorized by slab on grade, crawl space, and basement. If you find that the competent soil right below the substructure here, it can be slab on the grade. Also, if you find that there's some strong competent soil here, and then you can just make in the crawl space as well. And then if you design the basement, and you design the foundation right below basement slab, it can also called as the shallow foundation. The next shallow foundation type, grade and beam. The grade beam is another shallow foundation option for supporting load. The ground reinforced concrete beam transmit the load from the bearing wall, simply designing the beam on the grade, and then this beam supported by the earth, and then this beam also support the retaining wall. It means this beam, the grade beam, support overall building weight. And then each file, which is you can see there's a little bit thicker beam here. This is supported by the pile, and the pile is connected to the competent soil. Okay. So next type, the mat slab. The mat foundation or mat slab is typical method of the slab on the grade. I think this is a very popular method, mostly because if you're just simply making a thicker and stronger slab, and the slab itself to support to the building weight. The mat slab consists of the reinforced concrete slab covering the entire area of the bottom of the structure. This kind of main foundation structure to support the building weight. It is large, thick concrete slab that sustains the load. It means whole slab area works as the foundation. Okay. So I just kind of bring the one video. So watch the process of the mat slab construction. Okay. You can see the retaining wall and excavating the ground, and then so designing the foundation, which is the design of the mat slab here. You can see the rebar, so making up the rebar, which is the reinforced concrete, and then working the rebar, and then connect to the column rebar, and then slab, the mat slab here, and then So ready to working on some concrete column after this. So next video to introduce about how we can consider about the math lab at the multi-story basement. Okay, so watch this video together and then we talk about the deep foundation.
With over 28 years of experience in the industry, we are proud to have the opportunity to tender for the substructure package of the German House project. The overall project includes 25 stories and 4 basements. The basement is about 22 meters deep and will be constructed by the semi-top-down method. We are fully confident in carrying out this project, a major development for Ho Chi Minh City. From the accessway on Le Van Hoon Street, go into the main gate and go straight into the site. The contractor's site office is located along Le Yuan Street. For the electrical system for construction, Huabin Corporation will install a transformer. Water supply and drainage will be transferred after the diaphragm wall and piling contractor are finished. Firstly, Huabin Contractor will install a tower crane using the luffing tower crane. Basements will be constructed using the semi-top-down method. We will use one opening at the lift floor for transporting rebar, formwork, and soil works. The construction site will be divided into 4 zones. The capping beam will be constructed first, while the luffing crane is being installed. Level 1. Excavation from existing GL for zones 1 and 2, followed by excavation from existing GL for zones 3 and 4. And place lean concrete work for zones 1 and 2, followed by reinforced concrete of level 1, zones 1 and 2, and lean concrete work for zones 3 and 4,
the first below
followed by reinforced concrete
level
for level 1, zones 3 and 4, and installation of struts for level 1. Basement 1, excavation for zones 1 and 2.
Excavating down. So we can call
followed
top
by
down
excavation for zones 3 and 4.
Which is
and
constructed from the
reinforced
top to bottom rather than
1,
bottom to top.
Slab zones 1 and 2. Excavation to minus 9.3 meters for zones 1 and 2. And reinforced concrete work on basement 1. Slab for zones 3 and 4. Basement 2 to basement 3. The construction sequence will be the same as basement 1. Basement 4. Excavation from the bottom level of the basement 3 slab down to minus 16.45 meters. Installation of bracing beam system for king post at basement 4 floor level. Foundation and STP tank level. Reinforced concrete for part of B4 slab and excavation from level minus 16.45 meters down to lift core foundation and STP tank level. Foundation and STP tank level. Reinforced concrete of the bottom slab of the tank. Reinforced concrete for mat foundation in single pour by using the low heat cement in combination with using the new generation plastic to minimize water demand and optimize mixed design components for controlling the temperature. Reinforced concrete of basement 4 slab in the remaining areas. Remove temporary struts at basement 4 level and reinforced concrete for
and then
columns,
the core will construct over the mess
basement
slab.
3 slab at opening area. Sequence as above. Huabin Corporation will remove temporary struts and casting concrete for shear walls and slabs from basement 3 up to level 1 in opening area and construct ramp. Stair at the same time. Finally, remove king posts outside the column. Huabin Corporation will always be a trustworthy, faithful partner.
So now we're understanding about how we can design a mess lab at the multi-story basement. So this video shows the top-down condition, which is constructed from the top of a basement, and then later space the bottom of the basement, and then the bottom of basement, they construct the mesh slab, and then the core rotating over the mesh slab. Okay, this is kind of main structure construction process. Now we talk about the deep foundation. So if the soil is weak or unstable on the bottom of the building, you have to consider deep foundation. Okay, so deep foundation transmit the building load to deeper and more stable soil. So in this case, you can see this is a ground condition, and then probably that part is unstable soil. So that's why it has to find the computer soil. That's why you have to be penetrating up to this point. Okay, because this part is computer soil. It is called as the deep foundation. Okay, deep foundation mostly categorize caisson or pile. So this is all possible deep foundation method and material. So you can decide materials such as timber, steel, composite, or concrete, depending on the construction type. But mostly, the concrete is most popular, the deep foundation column material. So I think it's kind of also talk about the caisson, how we can construction. What is about the construction process for the drilled caisson? So first one, you have to be locate the guide wall. Okay, and then it has to be drilled into the earth to find solid layer like a bedrock. Okay, then add rebar into the hole and pour the concrete and remove the guide wall and closed caisson cap to protect drilled caisson. Okay, so that's why it is kind of a pretty easy actually making the drill to find the computer soil on the bottom, and then adding the rebar and then pour the concrete, which is making out the reinforced concrete, then the cover the caisson cap. Okay, and then you can build above the ground level. So this is kind of construction image. You can see they just drill the hole here and then adding the rebar, and then they just pour in the concrete. Okay, sometimes the load is heavy, they need a more the file to support the one single point. In this case, you can consider the clustered pile, which is bundled pile. The several file support the one single pile cap and a column locating over this pile cap rather than one single pile. Okay. So next type is lambda aggregate piers. The lambda aggregate piers is another option for the deep foundation. It is patterned ground improvement system. It uses the compact aggregate to create steep pier element. Process is very simple. It required the temp the aggregate down hard by compactor after excavating the earth. I think this is a very new technology, but it's very eco-friendly method because it's kind of simply making out the hole, and then they just adding the aggregate and using the compacting machine to compacting this aggregate, and they keep going from the bottom to top to making out this the deep foundation pier. Okay, so just kind of watch this video to understand better about the lambda aggregate piers. Okay, first drill the hole and pour the aggregate, and using the compactor, then adding the another aggregate and using the compacting machine. So another aggregate, compacting machine to making the continuous deep foundation pier. Okay, So this is kind of another new technology and a new option for the deep foundation. Okay? So now we're understanding about what is shallow foundation, what is deep foundation, why we need a shallow foundation, why we need a deep foundation, how we can categorize it, what is our different construction process. Okay? So now after designing on the underground, especially basement, so now we have to talk about waterproofing and drainage at the foundation. So this is a very important detail at the foundation design, because you have to get out of the water as much as possible from your foundation. So this kind of getting out of the water and drainage and waterproofing is relating to the structure safety. So let's talk about the foundation assembly detail. The first one, you can see the concrete wall, concrete retaining wall, and the footing here. So over the concrete, we usually add drainage mat and waterproofing membrane, and you can also see the two different drainage pipe. Okay, and the drainage pipe, they're covered by aggregate. So you can see also drainage pipe. One is perforated drainage pipe, and the second one, it is more about the solid the drainage pipe. So we look across waterproofing detail such as drain map, drain pipe, and waterproofing method. Okay, so let's look at the one by one. So let's talk about the drainage mat here. So okay, over the concrete, and at the underground, we always setting up the drainage mat. So drainage mat here, drain mat. So this is dual composite drain. It's a filter fabric. It is usually dimple pattern fabric. So means it is extra the protection from the earth. Usually above grade level, it doesn't require this drain mat. It's only require the waterproofing. But when you're making out the underground wall condition, you have to be set up the drain mat before waterproofing membrane. Because what is about the function about this one? The dimple pattern looking surface collect water, then it's much easy to redirect the water to the drainage pipe here. Okay, so this one you can call it drain mat, and then over the top of a drain mat you can simply adding the waterproofing membrane. Okay, and next one, you have to be concerned about the drain pipe. What is about the function of a drain pipe? It collects water from the earth, from your building, and then getting out of the water, it usually conducts water away from the substructure. So there's a two drain pipe type required, which is perforated and non-perforated. So you can see the two different type here. The perforated here and non-perforated type here. Non-perforated type usually connected from the downspout, simply getting out of the water from the loop. Okay, just can collect the water from the top, and then just getting out of the water from here. It doesn't require the perforation here. However, you can see the drainage pipe here with the perforation. So this one actually getting out of the water from the earth. The earth usually contains lots of moisture. So it means you have to take that out the moisture or water from your foundation. So this perforated drainage pipe is function to getting out of the water from the earth. So this perforated pipe, the covered by the aggregate usually. So why we need this aggregation around the perforated pipe? Because it locating right next to the earth. Earth has very small particle. It's very easy to penetrate into the pipe if you're having the perforation. So it means easy to clogging. So that's why it's a big problem to getting out of the water, right? So that's why if you having some aggregate around the perforated pipe, it is protect the earth to coming into the pipe, but still getting out of the moisture and water out of the earth. Okay, so you can just consider the aggregate. You can see the perforated pipe with aggregate around. Also, these days also you're using the fabric socks. So this is a perforated pipe, and then with a foam with some fabric socks, it also protect the small earth particle, but still getting out of the water from this. Okay. So now you can see how foundation drain pipe works from your home. I think this animation is help to understanding how this foundation drain pipe works for your the housing design. Okay, let's watch this first. You can see the old draining system on the bottom. You can see the perforated pipe. This keep collect the water or moisture, and then this one actually connects to the public sewage system, getting out of the water. This is a public sewage system. Okay. So next one, we talk about the waterproofing. The waterproofing also consider the two different protection: the damp proofing, waterproofing. What is different between the damp and water? So damp proofing is the type of moisture control applied to the building wall and floor to prevent moisture. The waterproofing simply just kind of protect actual water. So damp is protect the moisture, water is protect actual water. Okay, so it means you remember about the waterproofing membrane, and also we can have in the water the vapor barrier. So remember the vapor barrier wall, it is protect the moisture. The waterproofing is protect the water. It's same thing. Damp proofing at the ground level, below ground level, it protects the moisture. The waterproofing protect actual water. So it means, so when you're designing about the retaining wall on the bottom or connecting the joint between the floor and the wall, you always have some joint between. Even the very small gap, the moisture and water is very easy to coming into your place. Okay, so it means it happens to loss about condensation and making out the loss of moisture into the basement. That's why you have to be protect very well between the component through this gap here. So especially you can using some spray. You can see the concrete panel joint here. So this joint usually very narrow. It's hard to getting into the water, but moisture is the passing through. But that's why you have to protect the moisture transfer from outside to inside, inside to the outside. So from this region, you have to be protect very well. In this case, we usually using the spray over the retaining wall. Also, you can injecting the sealant for the joint. Okay, so this is very well to protect the moisture transfer or water transfer. Okay. So next one, you can see the waterproofing membrane better. So on the wall, you can see that this is a drain mat. Okay, and then over the drain mat, you are simply adding the waterproofing membrane. This is second water protection for the basement wall. Okay. So now we just kind of simply understanding what is difference between the damp proofing and waterproofing. So damp proofing treatment of surface to retard the absorption of moisture in the without hydrostatic pressure. So it means it's more related to the moisture. You remember why you make the moisture? Because inside and outside have a different temperature, whereas air moving from the higher temperature to the lower temperature. When this air moving to the outside inside or inside to the outside, when they meet in the dew point, the air change the water, right? So this is called as the condensation. You remember we talked about this issue from the last semester. So that's why we always consider about the protecting the moisture when it has some air, right? So means we always consider about the moisture. So means you need damp proofing at the ground, at the basement design. And then you need the waterproofing. The waterproofing here, the treatment of a surface to prevent the passage of liquid water with hydrostatic pressure. So it means simply protect the water pressure from the outside. Okay, you probably have to be understanding what is the difference between the damp proofing and waterproofing. Okay. So now I just kind of draw out the simple, the underground and ground condition detail word section. So I just kind of explaining about how you design and how you consider to design actual the foundation and ground condition design. Okay. So first one, you have to be understanding about the designing the main structure. You can see the actually footing here on the bottom, and then this slab. And then I also adding the 6-inch concrete curb here. It's not necessary. Simply you can add the concrete and you can adding some metal stud over it. Okay, so this works. But at the ground level, I usually the research about 100 flood level. What is about the most serious flood impact to the site? So means it have to be provide the protecting this flood into the building. So that's why I just adding the 6-inch concrete curb here. So means this ground level. Actually water at the flood, each water level is here. If without this curb, water getting into the space. However, when you designing the concrete curb here with the waterproofing, it actually protect the water up to this point. Okay, so that's why I proposed 6-inch concrete curb at the stud wall. I think this is more about the practical technique. Please kind of remember about how you can actually protect your water the better. And then we're adding the insulation. You remember about the exterior insulation with the reinforced the rain screen system, and then we're also adding the same interior insulation here. Okay, to meet the minimum R value. And then you have to protect the water. So simply you can adding the waterproofing membrane and then vapor barrier inside, and then waterproofing all around here. Okay, just protecting your structure and foundation. And then simply adding the finish wall here. Okay, finish wall and finish floor. Well, you can also, for the basement, you have to be adding the 2-layer, the waterproofing membrane and the drain mat. I draw the drain mat out of the waterproofing membrane, but this is up to you. You can draw the drain mat first, and you can adding the waterproofing membrane outside, or you can adding the waterproofing inside. We can just draw the drain mat outside. Okay, but it's totally up to the site condition, totally up to the company. All right. So today is kind of we talk about the lots of different foundation type. You remember about how you can find out the computed soil and how we research and how we getting the information about from the geotech engineer, and then how we using this data to design the foundation. Also, we talk about when you find out the computed soil, we also talk about how you excavating the ground, right? And then what is about the process, what is about the shoring process. And then when you're excavating the ground, so if you find that water, you have to be dewatering from the site. Okay, after dewatering and dried and excavating it, now you time to design the foundation. You remember the foundation is locating below the substructure, and over the substructure you can call it as the superstructure. Remember the 3 different parts. So the foundation has also divided by 2, deep foundation and shallow foundation. What is about the deep foundation? If your earth bottom of the substructure is weak and unstable, you have to be making out the deeper to find the computed soil. It is called as the deep foundation. Okay, and then shallow foundation. If you find the computed soil right below the bottom of a substructure, you can just choosing the shallow foundation. The most common shallow foundation type is the mat slab. Okay. And then you can also remember about the deep foundation also has the file and pier and caisson. You remember also how you can install and construct the caisson. We also talk about this process as well. Okay, so we talk about the many different things. Also when you design the basement, also how you can design the waterproofing, and what is about the drain mat, and how you designing the damp proofing, and how you designing for the waterproofing. Also, you remember about the 2 different drain pipe type. First one is solid drain pipe, and then what we also talk about the perforated drain pipe. Also, you have to remember what is different the function between the solid drain pipe and the perforate drain pipe. Okay, so this is our topic for today. Please email me or just meet in the Zoom during the class time if you have any question. Okay, thank you guys, and then hope you guys enjoy the lecture, and then just email me if you have anything else relating to the lecture.